Paola Inverardi, professeur à l'Université de l'Aquila, Jérôme David Bromberg, maître de conférence au l'abri, Valérie Sarny, directrice de recherche et directrice de la thèse, et moi-même, Sébastien Tixeuil, professeur à l'UTMC. Vous avez maintenant 45 minutes pour nous présenter vos travaux.
Merci. Hello everyone and welcome to my PhD defense. Which has entitled Dynamic. Yes. Sorry. It's not part of my speech.
So maybe better that you have started the presentation of the book.
Okay. Is it better? Yeah, I just started. I'm just starting. Okay. So my PhD thesis is entitled Dynamic Synthesis of Mediator in Ubiquitous Environment, which I did within the R project team under the supervision of Sarny and from INRIA, and it was also within the collaborative project, the European project, which was called Connect. So to try to keep you awake for 45 minutes, I will tell you about one example that interests me. So we all use some file sharing systems, basically to read, write files and to share them with our collaborators. And to do that, there are plenty of applications that are available. So some of them are standards, like WebDAV, for instance, and some of them are proprietary, like Google Doc. And each application has its own way to represent its information. For example, its own way to represent files and the action that can be performed on these files. So we end up with a heterogeneity between the interfaces of these different applications. Next to this heterogeneity at the interface level, there is also differences at the way these actions has to be performed. So, for example, some impose to lock a file before accessing it, some others doesn't. So, which create a heterogeneity between the behaviors of this application. Moreover, usually they are never standalone. They are distributed across several devices, which means that they have to exchange information over the network. So, and to exchange this information over the network, they have to define a certain format of the messages and also an interaction protocol to exchange these messages. And each one has its own format, its own protocols. So we end up also with a diversity of middleware solutions. And which exacerbates the situation is that now, with the widespread of phones, of tablets, etc., these devices have a tendency to move. So, and we don't know when one of the systems finds itself within another component. So what happens? They are not able to interact. So to solve that, we use some intermediate software entities called mediators. So the mediators tackle and overcome the heterogeneity at the application and at the middleware layers. And since we don't know a priori which systems are going to interact, we need to join them at runtime. So from now on, I concentrate on this simple example during this presentation, which consists in a WebDAV client, which is, for example, the Finder on a Mac, and a Google Docs service. And I show you how we generate a mediator for them. So my thesis statement is components which have compatible functionality. So I need a file sharing system. There is a file sharing system should be able to interact despite the heterogeneities at all the layers and across the interface and the behavior. And to allow them to interact, we dynamically generate this mediator and deploy them in their environment. So to do that, we rely on ontologies, because if we consider only system, we cannot reason about them automatically. So we need some models, first of the systems and of the domain. So each domain has its own concept, and we need to know these concepts. And the ontology gives us a machine processable model of the domain. And based on the models of each system, together with the ontology, we synthesize this mediator. And then we deploy it to actually allow the heterogeneous component to interact. So there is a phase of model extraction, but I don't focus on it. For me, I focus on the synthesis, and so I assume that the models are provided. So I have the models of the component together with the ontology, and I generate the mediator and deploy it between the systems. So I'll go more in detail into these models. So building over the work that has been done in the semantic web services, we assume an ontology-based model of the component. So first of all, we want to have some method name authenticate and some arguments, username and password, and then receiving the response, which is authenticate and the authorization. So based on these models and the ontology, then we go for dynamic synthesis. So there are several steps. So basically we concentrate first on the application level, where we can reason about the domain and prove some properties, and then go to the middleware level, where we can actually achieve the interaction. So at the application level, we first match the interfaces of the components. So, and here, the real contribution is to go beyond the one-to-one correspondence and to be able to extract many-to-many correspondences, which means that not only one action can be matched with one action from the other interface, but a sequence of actions from one interface can be matched with another sequence of action from the other interface. Then, based on this interface matching, we go to the behavior, and we try to coordinate the behavior of the two components in order to guarantee that their interaction doesn't lead to any deadlock. And the real contribution here is that we don't assume that we are given a perfect interface matching, but the interface matching may contain some ambiguity, which means that the same action or sequence of actions may be associated with many. So we have to deal with this ambiguity while generating the mediator. Once this mediator is generated, we go to the concretization. So how to turn the synthesized or the generated mediator into an actual software by taking into account the communication protocols. And here also the contribution is not only to consider middleware of the same interaction pattern or the same middleware, but we consider also middleware of different interaction patterns. And here all the importance of the application level, because when there is different interaction patterns, the application is so different that it's important to go also these two different steps. And also the major outcome is that there is a unified approach. So we don't consider only application, but we go to all the layers, going from the theory to the practice. So from proving, etc., into actually achieving this. So I first start by taking the interface matching. So, and coming back to our example, intuitively, if we want to identify all the correspondences between the interface, we will pick, let's say, one action put in a more general context. So if we take, for example, like 20 years ago, the software, and even now actually, even now, the software were developed in a way that I write a program, I compile it, I give it to my computer, and it executes and life is nice. Except that this can only be computed, done for software that are not very complex. And now, with the data that are available everywhere, etc., we go to another step. So I don't write a program that do what I want, but I can give it some examples and show it how it works, and the program can be extracted by itself. And this is the learning. And there is more and more progress, and we see, for example, with IBM Watson, how they can do it. And there is the third one, which is not already available, but I hope someday it will be. It's the, we don't want just to give example, we want systems that are able to identify the examples, identify how the software can be worked. And here, this emergence of behavior, emergence of the program is more important. And here where the dynamic synthesis of PhD play a little step into this by allowing software to interact in order to create this emergence. So, thank you. 45.
Thank you very much for the timely comme le jury a maintenant délibéré. Nous avons trouvé que vous avez effectué une présentation claire, bien structurée et équilibrée entre théorie et pratique. En particulier, on a apprécié que les contributions à l'implémentation des solutions que vous avez développées pendant votre thèse étaient données à des logiciels fonctionnels. Le jury a estimé que lors des réponses aux questions qu'il vous a posées, vous avez démontré votre maîtrise du domaine et votre capacité à intégrer des perspectives différentes, donc des méthodes formelles